In the last month of this semester, and next week you have spring break. I hope you all know.
Yes, sir.
So, any plans for spring break or staying home?
Spend time with our relatives.
Okay. Nigel, how are you doing?
Me?
Hmm.
Good.
Yes, you.
I'm doing good.
How are you coping with all the classes?
Yeah, I've worked a lot of hours.
Hmm?
Yeah, I'm caught up with this class.
Hmm.
Caught up with this class.
How many classes you are taking this semester?
I have two. I work a lot of hours. I do Uber and Lyft and DoorDash.
You work also?
Yeah, I do Uber and Lyft and DoorDash.
Oh.
That's a lot of hours.
Oh my goodness.
I have a question for you.
Yeah. Right.
If we were to be able to pass the Network Plus, would you be willing to swap a grade out for that?
If we would.
Pass the Network Plus
Hmm.
certification?
Hmm.
Would you be willing to swap a final or a final project for that
Okay.
as a grade?
Before the final, if it happens, then I don't mind doing it.
Okay.
Yeah.
Any plans for you for spring break?
You know, we are coming to the campus. We are not completely off. Instructors or staff doesn't have a spring break like you guys. Only the classes off for students, but not for the staff. So, but anyways, because of my my health reasons, I'm not. Even I'm not taking any leave. People used to take leave when we have spring break like this. Okay, let's look at. By the way, I hope you guys have seen an announcement I posted yesterday. No, day before yesterday. On Monday, I posted it for a guest speaker on Wednesday. So today, and at 2 o'clock, in room number 304 on third floor, there will be a guest speaker who is working as a principal network engineer in a company called RICO, RICOH. This company is, if you know, involved in printing business. And this person is, because he is a principal network engineer, who is looking after the networking, security, and system administration of the company, and also visiting company's data center several times in a year. I would suggest and highly recommend that you should attend this lecture. Maybe you will get the answer of some of your questions related to your career. Maybe you can ask questions that if you have anything in your doubt, if you have any doubt about your career in your mind, or should I go for cybersecurity or for networking or something. So he's a very experienced, very experienced person of more than 3 decades of experience in IT. He has seen almost all the major changes happened in IT industry. So he is visiting, and it's at 2 o'clock today, room number 304. again, those who are here in the class, if you attend by either online or in person, I would recommend attending in person. Will have more impact. But even if you attend online, just let me know that you have attended. You can, even I will be there, so I can see who all are attending. So I'll square your, or I will maximize your grade in one of the lowest score you have. Maximize your grade in one of the lowest score you have in any quiz or lab or anything. Okay, except finance.
What's today's lesson about?
Huh?
What's today's lesson about?
Today's lesson is about it's going to be lesson number 8. I was coming to that, but you were. So yes, last week we were talking about network segmentation or what? Yeah, we were talking about network segmentation last week, and let's start with this video on packet tracing. Okay, so let's watch this video first. Add VLANs. How we can add VLANs in the packet tracer. Now, VLANs need to be added with a proper planning. You just can't add VLANs because my switch supports VLAN. For example, this is a room. This is a room, and we have a plan to sit 40 students or arrange 40 students in this room. But because this room is too big, so let's partition this room into 4 different rooms without any thought in the mind, and you just partition. Will that be useful? The answer is no. That won't be useful. So your VLANs need to be created with a proper planning, and you need to know which all computer or computers you would like to add into that VLAN. So watch this video.
Hi y'all, I'm Jill West, author of the CompTIA Network Plus course from Cengage. In this video, we'll be working through the project Add VLANs to your packet tracer network. Now in this chapter, we're returning to our packet tracer network. In an earlier project in the chapter, you will have added several subnets to your network. In this project, you add 2 VLANs to your network and you enable communication between the VLANs. So let's get started. Here in our packet tracer network, we first need to create a little bit of extra space over here on the left side because we'll be adding 3 new PCs to this one switch 0 over here. So the easiest way to do this, make sure your window is expanded a bit so you have some space to work with. Press and drag across your entire network to select all of the different components. Then you can let go. Then grab any one of the selected components and drag the entire network over to the right just a little bit. You need a space over here to add your other PCs. Then you can let go and click outside of the network to deselect all of the components. Next, we need to add 3 new PCs to the network. So let's go to the End Devices category, click a PC here, and we'll add it to the network down here. Then let's grab another one, PC 8, and one more, PC 9. You can reposition these a bit so you've got some space to make your notes later. Remember, you'll need to add documentation for IP addresses, subnet masks, and default gateways. Next, let's connect these new PCs to our switch 0. So we need the connections category. We'll use copper straight through cables. For each PC, of course, we're connecting to the fast Ethernet 0 interface. For the switch, we're connecting PC 7 to fast Ethernet 03. And then we need another cable. PC 8 goes to the connection on the switch, fast Ethernet 04. And finally, PC 9, grab a copper straight through cable, fast Ethernet 0, and on the switch, it's fast Ethernet 05. As these connections are coming up, we need to go into the switch and configure our VLANs on the switch. So click switch 0, and we're going to the config tab, and on the left in this pane, you have the VLAN database page here. So click this option, and here you can see we have a few VLANs that exist already. VLAN 1 is the default VLAN, and then we have a few VLANs that are just on Cisco switches by default. We need to add 2 new VLANs. So first, the VLAN number is number 2, and the name of it is accounting. So type accounting up here in VLAN name, then click the add button. You can see it's now added to our list of VLANs down here. Now we need one more, VLAN number 3, and this is the sales VLAN. Then click the add button, and now we have our 2 new VLANs listed. VLAN 2 is accounting and VLAN 3 is sales. Logically, the VLANs now exist, but they need to have interfaces from the switch assigned to these VLANs. So to do that, we need to go to the configuration page for each of these interfaces. We'll start with Fast Ethernet 01. Currently, by default, this interface is using the access mode as opposed to the trunk mode. We don't want trunk mode, we want access, so that part is correct. But by default, it's assigned to the default VLAN, VLAN 1, and this is what we want to change. So we want this one to be VLAN 2 instead of VLAN 1. So just check that box. You can see down here the switch port command confirms the access mode and then assigns the...
So you notice that how the commands are executed when you are doing something with the switch. So when you are activating the VLAN, or you are getting into the VLAN by using this command, switch port access VLAN 2. So it is giving you command parallelly, so that if you want to learn, you can learn the VLAN commands, or you can learn these commands as well.
Interface to VLAN 2. We need to do the same thing for the other interfaces that are connected to our other PCs. So Fast Ethernet 03, which we just connected to PC 7, needs to be changed to VLAN 2 as well. And then Fast Ethernet 04 goes to VLAN 3, sales. And Fast Ethernet 05 goes to VLAN 3, sales. So we now have 2 interfaces assigned to VLAN 2 and 2 interfaces assigned to VLAN 3. Let's jump over to the CLI tab and confirm our configuration changes. Currently, your prompt probably shows the interface configuration mode where it has that config-if in parentheses. So we first need to exit out of that mode. From here, we can enter the command do show.
What this command does? This command here, interface Fast Ethernet 05. Anyone?
Like switching the command to, to configure that port.
Who was saying that? Okay, say it loud so that everyone.
Was I right?
I didn't hear you.
Oh, is that like changing, putting the interface, putting the command line to be like configuring that Ethernet port?
Right, so when you are willing to configure your Ethernet port 05, and you are willing to configure this port, so you execute this command, interface Fast Ethernet 05. After this command, you can see your prompt. Your prompt changed to config if not the English if, it's interface, IF, interface. So you are now connected to the interface port or interface which is 05. Here it is not showing you the name of or number of the interface, so you have to remember that which interface you are connected to, right? Same as interface Fast Ethernet 04. So after connecting to this interface, whatever command you execute or you are going to execute here, like this command, will be executed for this port.
VLAN and press enter. Here's the output that we expect. So we have our 2 new VLANs. VLAN 2 is accounting, VLAN 3 is sales, and each of those VLANs has 2 interfaces assigned to them. VLAN 2 has Fast Ethernet.
Now, can you tell me that which VLAN is the default VLAN and what are the ports in that VLAN? Which VLAN is the default VLAN and what are the ports in that VLAN?
01 default?
Huh?
Is 01 default?
01 is the default or 1 is the default, and what are the ports in it? So all the ports except these 4, or in other words, by default all the ports they belong to VLAN 1. All ports, by default all ports are in VLAN 1 in every switch, including your gigabit Ethernet port and fast Ethernet ports. So all kinds of ports are in VLAN
01 and Fast Ethernet 03, and then VLAN 3 has Fast Ethernet 04 and Fast Ethernet 05. So this looks good. You can press Tab to exit back to the prompt. Now remember, for each of these interfaces that are connected to the PCs, we needed to use access mode because only a single VLAN should be able to communicate over that interface to the device connected to it. It's different though for this interface that's connected to the router. This interface needs to be configured with trunk mode so that it can handle traffic from multiple VLANs. Remember, it has to send that traffic to the router in order for traffic to cross VLANs, even if the VLANs are configured on the same switch. So for example, if PC 0, which is on VLAN 2, wants to talk to PC 9, which is on VLAN 3, that traffic has to go through the router in order to reach PC 9, which means this interface from the switch to the router has to be configured with trunk mode.
So even if these ports are connected or computers are connected to the same switch, they cannot communicate directly because they are in different VLANs. Huh? They cannot talk to each other. For example, you are sitting in this classroom and I divided you guys into 3 groups. Consider them 3 VLANs. So if you want to talk to other group member, you can send that message to me and then I will pass that message to the group. Something like that. Otherwise, if you are part of the same VLAN, or if I allow you in a way that you can talk to other group members, so by default, the computers are allowed to talk to other VLAN members or VLAN computers, but you can change the mode so that they won't be able to talk to others.
To do this, let's go back to the config tab, and the Fast Ethernet 02 interface is the one that's connected to the router, so click here. This time we want to change the mode from access to trunk. Let's confirm our configuration change, so we'll go back to the CLI tab. Click down here just to get your cursor blinking, press enter to return to the prompt, and here you can enter the command do show interfaces trunk. Here you can see for this interface it's using trunking mode and it can handle traffic from multiple VLANs. Now before we leave the switch, we need to save the changes that we've made, because when this device powers down and then powers back up, it would lose these configuration changes. So we need to go back to privileged exec mode and copy the running config file to the start config file. To do that, enter the exit command once and then again press enter. Here, enter the command copy, run, start, and press enter, and then press enter again to confirm. All right, we're finished with the switch configuration window. We've configured the VLANs on the switch itself, but these new PCs still need IP address information. So let's start with PC 7, and we're going to the desktop tab, IP configuration. The IP address for this one is 192.168.43.29.
That will be the IP address configuration model. So let's skip that part. Okay, so this was our presentation last week. Let me see if we covered everything or anything was pending. We talked about, I think. Yeah, we have something. So we were talking about subnetting 2 weeks ago, where I told you that instead of using the whole octet, by default the entire octet is used to create the network. For example, so how we decide whether it is what is the network and what is the host? So it is always subnet mask. Remember it very clearly. It is always subnet mask which decides or which helps you in deciding what is the network part and what is the host part in an IP address. So if I gave you IP address like this, and if I ask you what is the network part in this and what is the host part in this, so you need to check. You need to ask a question. What is the subnet mask? So if I say subnet mask is this, what does it mean? /24. What does it mean? Correct. Right? So now if I know the subnet mask, so what does it mean? What does it mean for the IP address?
256 hosts available.
No. What is that word? Don't just subtract. Don't count by number. It's binary. It's binary. You are counting it by decimal. Considering it as a decimal, you are counting 6. Okay, 32 minus 24, 6. No. 2 to the power 6. Or it's not 6, it's 8.
Yeah,
Okay.
256, right?
And
255.
2 to the power 8 minus 2. Always subtract 2. Why we subtract 2?
Network ID, domain ID.
So first IP address in the range and the last IP address in the range will never be used. First IP address is always for network and last is for broadcast or for the entire domain or entire range. So if I have this subnet mask, that means because it is complete octet 255. What is the maximum number I can have in this octet? 255. So what is here right now? 255. That means the whole number is for network. 255, the whole number is for network. 255, whole number is for network. What is this here? 0. That means this is for, oh, sorry, not this. This is for host. So by looking at that number, you decide whether it is for network or it is for host. Now, if I have something different, let's say I have /23. Now, story changed. Now you have /23. What does it mean /23? 8 plus 8 plus 7 plus 0. Right? Always do these simple maths. 8 plus 8 plus 7 plus 0. That means all 8 bits for network. That means all 8 bits for network. That means 7 bits for network and 1 bit for host. Out of this octet which is of 8 bits, 7 bits are for network and 1 bit is for host. So how many bits already there for host? 8. 8 plus 1, how many bits now for host? 9. So total number of hosts? 2 to the power 9 minus 2 will be the total number of hosts in this network. Now these type of calculations AI can do for you very easily. But if you don't understand how it is doing, what calculation it has applied, if you don't know that, then that means you have to rely on AI with blind eyes or closed eyes. Okay, you close the eye and you rely on AI, and whatever AI is giving you, you use it. Okay, but believe me, that will not help you in interview. If you rely on AI, will not help you in interview. Interview, for passing or clearing the interview, you have to know how is this calculated. So watch as many as videos you want or you will get, and try to understand it clearly. So these are all about the subnet mask. Okay, so subnet mask table. So all of these IP addresses or type of IP addresses, class A, class B, class C, all these can be subnetted. Now, when you are subnetting, then doesn't matter what class is this, because it is always known as classless internet domain routing, or CIDR. And each class has a different number of host information bits that can be used for subnet, but don't worry. Now, determining subnets. So when calculating subnet, you will work with the following information: number of subnets, number of host addresses. But what kind of questions you may get in this? So you will get an IP address 192.168.0.0/24. create subnets for 50 computers each. Create subnets for 50 computers each. So you look at this network, and what is the subnet or CIDR number given? 24. That means 3 numbers or 3 octets are used for network, only 1 is used for host. So out of this 1, I need to create group of 50 computers. So we have to find out which number is in our series of 1, 2, 4, 8, 16, 32, 64, 128. Out of these numbers, which number is greater than 50? And so you will get this 64, which is the least or latest greater than 50. So you will use these many bits. You will use for host, right? These many bits you will use for host, and this bit you will give away to network. So 7 bits I will use for host, and 1 bit I will give back to network. So it will, the moment I gave 1 bit away, so I will add 1 bit here. So it becomes /25, and I have the how many computers or how many hosts or how many bits? Sorry, 7 bits. So 2 to the power 64 minus, 2 to the power 7 minus 2 will be 62. So I will have a group of 62 computers. So starting from 0, what is the 64? Where the 64 comes? 63. That will be your first group. Second group will start from 64 all the way to 127. Right? Third group 128 all the way to 191, I believe. And then 192 all the way to 255. So how many groups you get? 1, 2, 3, 4. 4 groups you get. So in this IP address, I can create how many subnets? 4 subnets. Okay. So if I ask the same question to AI, to some AI, let's do this. If I ask the same question to create 4 subnets using 192.168.0.0/24. It does the same
Too
thing.
much.
It does the same thing, right? But if I don't know this calculation, then I have to rely or accept whatever Google is saying with closed eye. I don't know anything. Whatever Google is saying, that is right. Okay. So you can look at this. Now implementing subnet on a network, so you can implement. Implementing is nothing but assigning the IP addresses. You can do other things also with this, like you put the different subnets in different VLANs. You can do this way. Every 50 computers, you can create a different VLANs and add all those 50 computers in that VLAN which is having a different subnet. See, all these are the part of network planning. When you are basically creating a network, then you will be doing all these things. Network services across subnet. So these are some services, you can read about it. Very well. This technique, whatever we just discussed, or whatever this technique is, right? This technique is known as VLSN, variable length subnet mask, or VLSN technique. So you can read about it. Now subnets in IPv6. In IPv6 addressing, we use no class. There is no class, there is no subnet mask. So a single IPv6 subnet can apply. See, what is that number? Oh my goodness. Can you read that number? How many billion trillions that number is? IPv6 addresses. So these many IP addresses can have one single subnet. In one single IPv6 subnet, we can have these many IP addresses. I don't know. I lost in counting. Right? Subnetting helps administrators manage the enormous volume of IPv6 addresses. So this is about the subnets in IPv6. So practically, IPv6 we don't need subnets, because if I start giving IP addresses to all these nodes, or considering all these number of devices are there on this planet Earth, that will create one subnet. So to have another subnet, we can have similar number of devices in it. Okay, so it's pretty simple. Right now, what is the network ID of the IP address? This /16 network ID. Can anyone tell me without taking help from Google or without looking at the PowerPoint?
B,
What is the network ID of IP address? Why you are saying B?
because of the 16s using the first 8 bits.
What? First 8 or first
16.
First 16 bits. So first 16 is 192,
168.
168, and then other will be 00. So 16 is how many octets? Joe, how many octets? 2, right? So what are the 2 octets? 192, 168. So that is 192, 168. So that's your network ID of this IP address. Now, can you tell me what is the, if I look at the IP address only, what is the class of this IP address? A, B, C?
Was it B?
Looking at the IP address, it is C class, but as per the subnet, it is B class. But because of the CIDR, we don't follow the classes. So any class can have any subnet in that case. That is your VLANs or virtual LANs. So we discussed about the VLANs. So VLANs are created to create a smaller network in the same network. Within the same network, you want to create much smaller network for the security reasons, for departmental distribution, right? For geographical distribution, you can create VLANs. And you can create VLANs or configure VLANs with the help of switch port configuration. So first you create the VLAN on the switch, or you activate VLANs on the switch, and then you add the ports. Add the port into the VLAN. By default, every port is part of which VLAN? By default, every port is part of VLAN 1. Okay. So whatever you are learning here, that is going to help you in coming classes. Okay. So study it sincerely. Now here you are, can we see the VLANs on a switch? Is the VLAN physical or logical?
Logical.
It's logical. It's all logical. Cannot see physical VLANs. The ports can be anywhere in the switch and can be a part of one VLAN. So you can learn about the VLANs here. You can also, now these days, by using spanning tree protocol, we can create VLANs across switches. Means we can have one VLAN where the ports belongs to 2 different switches altogether. 2 different switches, switch A and switch B, they both have VLAN 1. or they can have VLAN 2 and so on. So 3 switches on a LAN with multiple VLANs. You know the VLAN 1 is a default VLAN, and it is there on every switch. It is there on every switch. So that means VLAN 1 is available on multiple switches simultaneously. Now each port can have two types of VLAN configuration. One is access port. It is connects to the switch to a host, and trunk port connect the switch to a networking device such as router or another switch and manages traffic. So if I look at the diagram, if you look at this diagram, see this diagram? Now can you tell me what should be the type of this port? Look at my mouse pointer and what will be the consider that these all are my computers. These are my computers. So what should be the type of this port? Access or trunk? So remember, access port connects the switches to a host, and trunk port connects router or other switches. So looking at those two statements, what should be the type of these two ports? Access. What should be the type of this port? Trunk. What should be the type of this port? Trunk. What should be the type of these two ports? Trunk. Right? So that way you can clearly understand that what should be the type of my port. So you need to change the port type as well on your switch. Right? So with trunking, a single switch can support traffic belonging to several VLANs across the network. Now in this picture also, you can see each trunk line carries traffic for multiple VLANs. So if VLAN 1 wants to send some messages computer in VLAN 2, it has to go through all the way to the router and then comes back. So only the router can be used to establish the communication between the two VLANs. Right, in VLANs and subnets. So in most situations, each VLAN is assigned its own subnet of IP addresses. That's what I was talking about. You can have different subnets for every VLAN. So you have 4 VLANs and you have one IP address, and you divided them into 4 different VLANs. So like example we took before 192.168.0.0/24 divided into 4 subnets. So what I can do is I get 0 to 63 one network, 64 to 127 another network, right? And 128 to 191 another network. So I can create 3 VLANs in my switch, and I can assign these range of IP addresses to the computer in those VLANs. So VLANs can have their own subnets. Excuse me. Now, if you are using a switch which is capable of layer 3 traffic management, you can create a virtual interface on the switch, and that is called switch virtual interface, or the switch virtual interface, which can be used to handle the inter-VLAN routing for every VLAN. For each, it has an SPI. So what happens here in this case? Basically, your switch is capable of routing. So some of the routing functions are now available in the switch itself. That is called layer 3 switch. For example, your ADSL router at home, your ADSL machine, which is providing internet connection to you or to your house, is doing all these types of jobs. It is routing, it is switching, it is converting your wired signal into Wi-Fi signal. So it is doing all those jobs. So it has that capability to convert or to communicate, set the communication between different networks. So layer 3 switches are designed for this type of operation. So instead of going through the router for VLAN communication or inter-VLAN communication, now the switch is capable of doing it. So one VLAN can communicate to other VLAN with the help of switch only. You don't need to go all the way to the router, or your messages will not be going to the router to do the VLAN switching. Types of VLAN, so you have default VLAN, native VLAN, data VLAN, management VLAN, and voice VLAN. So default VLAN, which is typically pre-configured in all the switches and all the ports, belongs to that VLAN. Native VLAN receive all untagged frames from untagged ports, which are not the part of any other VLAN. Data VLAN or the user VLAN carries user-generated traffic such as email, web browsing, or database updates. Management VLAN can be used. These are the types of VLANs you can create. Now, depending on your work operations, you can add those ports. You can add the ports into these different types of VLANs. And these are some commands you can use to do the VLAN maintenance, such as the commands like show VLAN, which will give you the list of all the VLANs, including the ports in those VLANs. Some of the issues which can happen with the VLANs, like your incorrect VLAN assignment, your incorrect port mode, like access or trunk. VLAN isolation, you can potentially cut off the entire group from the rest of the network by doing the VLAN isolation. VLAN security. So for the VLAN security, you can use VLAN hopping. VLAN hopping occurs when the attacker generates transmission that appear to belong to a protected VLAN. Attacker then cross VLANs. So read about that. And that's your virtual extensible local area network, which is used for large size networks, which may contain or spread it across the multiple locations. So many data centers connected to each other across a data center interconnect, and that can be established with the help of VXLAN or very virtual extensible. Or basically you are creating, let's say there are 2-3 buildings in a data center and you want them to be a part of same VLAN, so you can use this type of VLANs there. Cloud networking. So in case of cloud, you can create VPC or virtual private computing network. In this VPC, what we do is we create a virtual network, or this is the building block, basic building block of any cloud infrastructure. So if you want to create a cloud infrastructure on any platform, which is AWS or Microsoft or Google, the first thing you create is VPC. VPC gives you a virtual private cloud. So your virtual private cloud is created where you can set an IP address range and a subnet. So all the devices which you are going to add in this VPC will get one IP address and subnet from that range. Inside that VPC, you may be adding some computers, which is VM, right? You may be adding some VMs, you may be adding some servers. So all those becomes a part of that VPC, and you will get the IP address. Now, if you would like to access this VM from outside this VPC, so you need a public IP address also on this VM, so that you can access this particular VM. Otherwise, every time you want to access this infrastructure, you have to connect to this VPC and then only you can access whatever is inside it. But I want to connect this VM from direct RDP, remote desktop. So I can get a public IP address on this VM so that I can directly do RDP to my VM. So VPC is the first step. VPC is the first step we take in building or creating our cloud infrastructure. This is about the network spaces in cloud, so you can also create segmentation in cloud as well, or you can do segmentation. Remember that private subnets or private IP addresses, whenever you connect to internet, always uses NAT gateway. NAT stands for Network Address Translation. Read it and watch some videos on NAT, which is very important for you to understand that how this private IP address can access the internet. Because private IP addresses are not allowed by default or in default in nature. Private IP addresses are not allowed to access the internet, but still we are having private IP addresses and can access the internet simultaneously. How does this happen? So it is happening because of this NAT technology. So read more about it or watch some videos on NAT. So this is an example of network space in the cloud where you can see you have a VPC created. So this is one VPC you created, and inside that VPC you have two subnets. One is private subnet, other one is public subnet. In the public subnet, it will be having public IP addresses, but in private subnet it will be having local private IP addresses. So with the help of NAT gateway again, you can connect to the internet. Okay, now the cloud at the edge. Now what is edge computing, or this edge technology is used in cloud? Basically, cloud systems cannot be everywhere in this world, right? On this earth, we cannot have our servers everywhere or in every corner, every city, every state in this of this country. Servers are centrally located. There are two zones in US, if I remember it correctly. One is West Zone and another one is East Zone. East Zone and West Zone. And we have, so how it is divided? So this, if this is your country, so country is divided into two parts. One is West Zone, other one is East Zone. Now in each zone, we have some regions. So we have, let's say, 2 regions in West Zone and 4 regions in East Zone. So every zone will have some data centers. Every zone have some data centers, and these data centers are called availability zones. So this is my region. This is my region. And these data centers now called availability zones. Similarly, here you may have data centers, and these data centers are known as availability zones. Availability zones may have multiple data centers in it. So there is one data center, another data center, and they are replicating to each other. Data center replicating to each other or replicating across the availability zone. This way they are protecting. Now, if I am sitting here in Lawrenceville and wants to access some service, let's say we have 10,000 users in this area, in this zone, accessing certain type of service of a company. So what the company can do to improve the performance of their service, they can create an edge location here in Lawrenceville. They can set up their edge server in Lawrenceville. So what the edge server will work? Edge server will work as a temporary cache or cache for the frequently accessed data. For any data which you would like to access frequently, or what the users, multiple users are accessing this data frequently, that will be placed or copied on this edge location. So what happens in this case? So the user sitting here will get a better performance experience. So edge locations are used for this type of operations. to improve the user experience. For example, it's the same case these mobile service companies are doing. They install the tower. Have you ever tried to study how these mobile technology works? You must do that. These are all kind of questions you should have in your mind. So they almost do the same thing. If they experience that users are facing performance issues in calls, the calls are dropping frequently, what they do is they set up another tower in that area. So the moment they set up the tower, the number of channels will increase and more users are now able to get the call. Same as the edge location is doing, edge location is keeping some frequently used data at the local location, and users can get the access, get the data there. Now let's say some data, this user is trying to access some data which is not here. So obviously it will go, the request will go to the nearest data center. Excuse me. The request will go to the nearest data center, and when the data comes back, the edge location will make a copy of that data. Edge location will make a copy of that data and also provide that data to the user. Another user wants to access the same data, so for that user, data is right available here. It need not to go to that location to get that data. So that way, it is something like there is a book, you want to read a book. The book is not on your table, not in your bag, it is in the library. So you go to the library and get the book, and now you are keeping it for a certain period of time. Until you are reading it, you are keeping it with you. So you are now having an edge location. Once you are done with that, you return it to the library. So once the user is done, user is no more reading this data for a certain period of time, that data will be removed from him. So this edge location is temporary storage for frequently used data. So this is how the edge works in cloud. Okay, that's all about this chapter. Let's take a break here and then we'll continue with the next lesson, which is lesson number 9, wide area networking.